Well, welcome. We're going to be doing factoring third degree polynomials using factoring by grouping. So only a certain class of third degree polynomials will be able to be factored in this way. And in fact, the technique I'm teaching, there's other ways in which to factor third degree polynomials under the integers. But this method is nice and always gets you to the right answer. So let's begin. If I had a third degree polynomial, trinomial, that looked like this, here's the technique that I propose. I would take, so our step one would be to look at this and look at the coefficients of the x squared term and the constant. Now, properly written, this would be ax squared plus bx plus c, where we call the coefficients of our variable a, if it has a square to it, so x squared. B is the coefficient of our x term, x to the first power, and x to the 0, or our constant term, is c. So what I'm saying is, step one is to find the factors of a times c. So in our example, the coefficient here is 1, and this is -6. So don't forget the negative that you put it in there. So we want to find all the factors of -6. Well, first I just think of factors of 6, which are 1, 6. 2 goes into 6 2 times. 2 times 3. I always put my smaller factors on this side and the larger ones over here, so that I'll know I have all the factors when I start to wrap around. In other words, my next factor would be 3, but I see 3, it's over here, so I know I've got all the factors of 6. Now I have to remember that I have to multiply these together to get -6. Now I have to think, how am I going to do that? Do I give the smaller numbers the negatives or the larger numbers the negatives? And the way that I determine that is I look at the sign of the middle term. Because with this technique, we are trying to find all the factors of -6, or the factors of -6 when added together will give me, that middle term will give me b. So that means when I think about that, we need to determine which factor gets the negative sign. In this case, negative sign, but gets what sign? So in here, since the middle term is a negative number, and I should actually add to that, based on the sign of b, that middle term. Since the middle term is negative, the factors when added together in step one must have the same sign. So I'm looking for a negative number, so in other words, my larger number has to get the negative sign. My step 3 would be add the factors. So 1 minus 6 gives me -5. Remember, I could have rewritten this as 1 plus -6. So 2 plus -3, or 2 minus 3, gives me -1. Well, I was looking at the two factors when added together give me -5, and I found it. So I would rewrite the middle term, -5x, as x minus 6x, because 1x minus 6x would give me 5x. So up in here, I now know how to rewrite my middle term. So I would say x squared plus x minus 6x minus 6. And now step 4 would be factor by grouping. So now it's time, as we did here, we started to work now in here. So when I started out, I went to another side of the paper to find all this, because I want to kind of keep them apart until I'm ready to work with my equation. And now I'm going to factor by grouping. So you group the first two together, and you group the last two together. So I look as if this doesn't exist, and I say, what can factor in the first two terms? And we see that x can come out of there. So I pull x out, and I'm left with x plus 1. Now I look at the second term, and I look at it, and I want the first term when I factor to be positive, so I'm going to factor out a minus 6. And when I do that, when I factor out a minus 6, I would be left with x plus 1. Because think, negative 6 times x gives me negative 6x. Negative 6 times positive 1 gives me the minus 6. So I know I factored it correctly. Now look what we have. We have two terms because these guys are being multiplied. These are being multiplied. So I have two terms, and I look at what factor is the same in both of these, and I see that x plus 1 is in both of them. So I can factor out an x plus 1. When I factor out an x plus 1, I'm left with a x minus 6. And I have now factored my trinomial. So I would say x squared minus 5x minus 6 equals x plus 1, x minus 6. And I factored my trinomial. Now, if in this first step I couldn't find two factors when added together would give me the middle term, that would mean that my trinomial is not factorable under the integers. But let's keep practicing with our trinomials and factor them using these steps. So let's look at this problem. In this problem, my a equals 1, my b equals 7, and my c equals 12. So I look for factors of 1 times 12, which is 12, positive 12, that when added together give me a 7. So that means both of my factors would have to be positive. So step 1, find all the factors of 12. 1 and 12, 2 and 6, 3 and 4. And again, both factors would have to be positive in order for me to add them to get a positive number. Because the only way I can get a positive number is either both are positive or both are negative. So both my factors have to be positive. Now next I want to find all the factors when added together would give me that middle term. So it'd only be one pair, so I go 1 plus 12. That gives me 13. That's not 7. 2 plus 6 gives me 8. That's not 7. And then I do my last one, 3 plus 4. That does give me 7. So now I know how to rewrite that middle term. So I would say x squared plus 3x plus 4x plus 12, because 3x plus 4x gives me 7x. And because this is true, I know that when I factor by grouping, I will be able to factor this trinomial under the integers. So let's group. So we group the first two. That would mean to pull out the x, and I'd have x plus 3. In the second group, I'd pull out a 4 because 4 is in common with all of them. And I'd be left, if I just pulled out the 4, I'd be left with x plus 3. See how it always works, that you'll have the same factor being pulled out if this is true. Once I see that, that means I can pull an x plus 3. It's in common with both of these factors. And what am I left with? When I factor it out, I'm left with an x plus a 4. And I have now factored x squared plus 7x plus 12. X squared plus 7x plus 12 can be factored as x plus 3, x plus 4. Let's try another example. So we're going to look at this trinomial where a is 12, b is negative 7, and c is negative 10. So step 1 would say, look at 12 times negative 10 and find the factors of negative 120. Well, the first thing, I'm just going to find all the factors of 120. Then I'm going to figure out which of the factors get the negative sign and which get the positive to give us the negative 120. So I'm just going to look at factors of 120. So I get 1 and 120. My next integer is 2. 2 does go into there because it's even. 2 goes into there, 60. I know 3 goes into 120. First, I can kind of just see it. But the trick would be is you add the digits of the number. 1 plus 2 plus 0 gives me 3. If 3 goes into that, then 3 is divisible by the complete number. So 3 goes into 120 because 1 plus 2 plus 0 is 3. 3 goes into 3 one time, so I know 3 goes into 120, and in fact it goes into it 40 times. I know 4 goes into it since I did 2 and that's still an even number. I know 4 goes into this. So 4 goes into here 30. 5 goes into 120 because it ends in a 0 or 5. The number does. So I know 5 goes into there. And I go 5 into 120. And you know, you can, if you have to, put it on the side. If you don't have a calculator, which you should be able to do this without a calculator, you could easily do this and know that 5 times 24 gives you 120. 6 goes into it because 2 and 3 go into this number. So I know 6 will go into 120 20 times. You know, I could even see that 6 goes into 12 2 times evenly and 6 goes into 0 0, that type of idea. 7 doesn't go into 120. There's no special trick, but I could do this and I'd say, and 7 doesn't go into 50. So I know 7 doesn't go into it. 8, does 8 go into it? Well, 4 still leaves me with a even number. I know 8 will go into it. So 8 into 120, 15 times. 9, well, if I take 120, I know 1 plus 2 plus 0 is 3. If this number is not divisible by 9, which it isn't, 9 into 3, it can't go into there. I know 9 won't go into this number. I know 10 goes into it because it ends in a 0. And that's 10 times 12. We knew that because it was right up there anyway. 11 doesn't go into there. You can prove it to yourself. 11 doesn't go into 120. And then I'd go to my next integer is 12, but 12 is right there. Once I wrap around, I know I got all the factors of 120. Now, determining, I got to look when the factors when multiplied give me minus 120. That means one of the factors has to be negative. How do I determine that? Once again, you look at the sign of the middle term. If the sign is negative, that means my bigger factor has to have the negative sign because we're looking at when the factors added together give me the middle term. So 1 plus negative 120, that's negative 119. That surely doesn't work. I'm going to look at, let's look at 2 plus negative 60. That gives me negative 58. That doesn't work. That's definitely not minus 7. So I keep doing this. And I keep going, wow, the negative number is much bigger than minus 7. 4 plus a negative 30 would give me negative 26. 5 plus a negative 24 gives me a minus 19. 6 plus negative 20 gives me minus 14. I do 8 plus a minus 15. There it is. That tells me I can rewrite that middle term with a positive 8 and a minus 15. In other words, I can rewrite negative 7x with 8x minus 15x. So I go up here and I rewrite it that way. 12x squared plus 8x minus 15x minus 10. So I now do factor by grouping. So I look in here and I say, hey, I can take out a 4 in both of these and an x. So if I take out a 4 and an x, I'm left with 3x plus 2. Now I look at these two, the last two terms. And when I do that, I don't want the leading term to be negative, so I'm going to take out a negative something. And I know 5 goes into both of these. So I'm going to take out a minus 5, and I'd be left with a 3x minus, no, a 3x plus 2. Because negative 5 into negative 15x gives me the positive 3x, and negative 5 into negative 10 would give me the positive 2. Oh, and see, I have my two terms with this in common with 3x plus 2, so I can factor it out. And what would be left? If I factor that out, I'd be left with a 4x minus 5. So when this goes away, I'm left with a 4x and a minus 5. And therefore, I factored my trinomial. Let's look at another example. 3x squared plus 20x minus 16. Again, in this case, a is 3, b is 20, and c is minus 16. So I take my A times my C and I try to find the factors of it. So I look at 3 times negative 16. I get a minus 48. So I want to find the factors of minus 48. So I just start out with looking at 48, all its factors. So I start with 1, it's 1 and 48. 2 goes into there, 24. I know 3 goes into there because 4 plus 8 is 12. And since 12 is divisible by 3, gives me an integer, I know 3 goes into it. So 3 goes into 48 16 times. I know 4 goes into it because this is still an even number, so 2 could go into there. So I know 4 goes into it. So 4 goes into there, 12. Plus I knew 4 times 12 is 48, but still, if you didn't know that, that's how I know that. Then I know since 2 and 3 goes into it, 6 goes into that. So 6 goes into 48 8 times. 7 doesn't go into 48. And then I get to 8, and now I've wrapped around because 8 does go into it, and we have all the factors. Now, since this is a negative 48, I have to find one of the factors has to be negative. So I have to know, is it the smaller factors that get the negative sign or the larger? Well, that's where I look to the middle term. Since the middle term is positive, that means the larger numbers have to be positive and the smaller numbers get the negative sign. So negative 1 plus 48 gives me 47. Negative 2 plus 24 gives me 22. Negative 3 plus 16 gives me 13. Still, I'm not seeing, what I need in here. And then I do negative 4 plus 12 gives me 8. And look, we keep going down. I don't see 20. Therefore, what this is telling me, if I can't find two integers when, the two factors when added together giving me that middle term, that means I can't factor this under the integers. So this is not factorable under the integers. And if I was told that we wanted to see factors under the integers, I'd have to stop there. However, it's not unfactorable. We could use something called the quadratic equation, which we'll learn later. We're just learning how to factor under the integers right now. So this wouldn't be factorable. But what if my problem changed just a little bit? What if I had 3x squared plus 22 minus 16? And again, I would take my 3 times negative 16, get my minus 48, and the factors would be the same because there's an x there. 3x squared plus 22x minus 16. When I get this, the factors would be the same. I'd factor it up, and then I'd look for all the larger factors being positive, the smaller being negative, and I would have found out that this would have been the way to rewrite the middle term. So the way I would do this again, it would still look the same, and I know that negative 2 plus 24 gives me that 22, that middle term. So I know how to break up the middle term as negative 2x plus 24x minus 16. And so factoring out here, the only thing I could factor out is an x, and I'd be left with 3x minus 2. Looking in here, what I could take out of both of these is a 4. Maybe even more, an 8 actually I can take out of here. Because if I take out an 8, I'm left with 3x minus 2. And now I've got that same factor in both. So factoring by grouping, I'd be left with this. And now I have factored my problem. What if I had a problem like this? Well, I'd look at it and say 3x squared plus 12x minus 36. Something I haven't spoken about in this particular video, but whenever we're factoring, we try to factor out as much as we can in any problem before we start like factoring by grouping or anything like that. So when I look at here, I go, wait a minute, I don't have to do 3 times 36. I can factor out a 3 out of the whole problem and I make my numbers smaller. So if I factor out a 3, I'd be left with x squared plus 4x minus, so I have x squared plus 4x minus 12. So now I'm looking at factoring this right here. So I'm looking at factoring x squared plus 4x minus 12. A lot better, smaller numbers than 3 times a negative 36. Now I have just 1 times minus 12, or negative 12. So I look at factors of 12. And I look at the factors when added together give me a negative number, but I want my middle number to be positive. So the larger ones get the positive sign, the smaller ones get the negative. So I'd have negative 1 plus 12 gives me 11. Negative 2 plus 6, there we are, gives me the positive 4. Now I know how to rewrite my middle term. I didn't need to do this one, right? So I can rewrite my middle term as negative 2x plus 6x. Factor by grouping. That one, factoring that out, factor out a 6, and I'm left with x minus 2. I see that both have x minus 2 in common, and what's left is an x plus a 6, and I factored out this. But in this problem, remember, there was a 3 in front, so now that I factored this term into this, I put it back in here, and this being completely factored would look like that. So I have now factored it completely. Now there are special cases when you have to factor difference of squares. So we have to remember that a plus b, a minus b, no matter what a and b are, would give us a squared minus ab plus BA, but BA we always write it in alphabetical order, would be plus AB minus B squared. Always the middle term cancels. So we find that A squared minus B squared equals A plus B times A minus B. And that was something I told you you really need to learn. A squared minus B squared equal A plus B, A minus B, or you could write it A minus B times A plus B. Doesn't matter. So if you were given a problem, you have to learn to recognize the difference of two squares. So if I had x squared minus 9, I note that this is x being squared and 3 being squared. This is my A and this is my B. So now I know A squared minus B squared equal A plus B, A minus B, so I can put them in here. If my A is x and my B is 3, I would have x squared minus 9 equal x plus 3, x minus 3. What if I had 4 x squared minus 16 y squared? I would note that these are perfect squares. This is 2x being squared, and this is 4y being squared. Now my A is 2x, and my B is 4y. So my A squared minus B squared equal A, which is 2x, minus B, which is 4y, times 2x plus 4y, my A plus B. So again, I could write it A plus B times A minus B, or A minus B, A plus B. So either one, I could have written it like this, or I could have written it like this. They're both the same. What if I had, let's say, 9x squared y to the 4th minus 25z to the 4th power. Then I note again, these are all perfect squares. I could rewrite this as 9x y squared, and not 9, but it would be a 3. Sorry about that. You basically take the square root of everything in here. So that would be 3, because 3 squared is 9. X squared is x squared, and y squared is y to the 4th. This is also a perfect square. That's 5 being squared and z squared being squared. So now my A is 3xy squared and my B is this. So I'd say, looking at this, a, which is 3xy squared, plus my b, which is 5z squared, and then my 3xy squared minus 5z squared. So noting that difference of squares, very important for us to do. Now we're going to look at a perfect square. Now these you could answer using the technique I showed you earlier with the factor by grouping, but it takes longer to be able to recognize this thing called a perfect square. In other words, when we work this out, we get a squared plus ab plus ba, which is the same thing as ab, plus b squared. We will always get 2 times the product of the numbers inside here. If I had a minus b squared, I'd have a squared minus ab minus ab. Negative b times negative b would give me a plus b squared. So I'd end up with a squared minus twice the product inside of there plus b squared. So if ever I see this square of a number, and I have negative twice their product, I know I have this perfect square. If I have the square of a number, the square of another number, and then twice their product in the middle, I have a perfect square. So how does that work? I note that this is a being squared. This is not a being, but x being squared. And this is 3 being squared. So my a is x, my b is 3. I look at a times b, that would be 3x. So 2ab would be 2 times 3x, which is 6x. And that's exactly what that middle term is. So therefore, this means this is a perfect square. It's x plus 3 being squared. If I had x squared minus 8x plus 16, I know that this is x being squared and this is 4 being squared. And I see the middle term is negative. So I know my a is x, my b is 4. So I look at a times b, it's 4x, and negative 2ab, since it's negative, is 2 times 4x, negative 2 times 4x, negative 8x. I note that I have a perfect square, that this is negative 2 times a times my b is in there. So that means this is x minus 4 being squared. Looking at squares. If I had 4x squared plus 12xy plus 9y squared, I'd note that this is 2x being squared. I'd note that this is 3y being squared. So my a is 2x, my b is 3y. So a times b is 2x times 3y, which is 6xy. And I look what 2ab would be. 2ab would be 2 times 6xy, or 12xy, which is that middle term. So this is 2 times my x times that y. So this is a perfect square. It's 2x plus 3y, my ab, being squared. So that's how you work with special degree 3 trinomials, my difference of squares, and using perfect squares. So thanks so much for watching.